Yeah, welcome all. So now we are going to see the another example of breadth first search method. In before going that, so we can just recollect the definitions and then process flow. So BFS it can be just to explore the nodes level by level using a queue. Okay, so it can be just to roll out the level by level using the queue. Okay, it visit all neighboring nodes before moving deeper and ensuring the shortest path is unweighted graphs. So that is the very important thing. And this BFS begins at the root node and it can be just visit every node at the current level and then proceed to the next level. It is widely used in the path finding and the network traversal and then web crawling and finding the shortest route. So this is the main theme of the BFS. So generally it will be as a graph based structure and it will be just traversing the tree based level, and this is it can be applied for the queue method, in particularly the FIFO, first in first outcome method. Okay, so this is the process flow, and it can be just focusing the level by level phases in the current position. Whenever we can meet with the 0th level and then first level, second level, third level, so we have to just move out the each and every level in the current position with the breadth basis. Okay, so breadth now how it will be, how does it will be move, like the starting into these positions way. Okay, breadth based. So this is one of the information of the breadth first search. So already we have discussed one problem of breadth first search. Okay, so this is the continuation for the other problem. So here the breadth first search, we are having the graph level with the help of the queue, and now we can start with the node of A, and then A it can be visited to the B and C of the children node and added into the queue basis, and B is visited by the C, and then we can continue with the level for the next thing, like the D and E and F and G. After completing the two levels, so final level combining the Hij, and since the BFS explore the every node at the level of moving to the next step, and finally we will get the traversal order for the continue level based and breadth based search of the data. Okay, and then ordering of the names. And now we are going to see the thing. So this is one of the tree based structure. So these tree based structure we can use with the queue technique, and then we can arrange with the traversal tree. Okay, so here the A and then A as a parent node, it can be as a parent node, we can consider the B and C as the child node. At the same time, B as the parent node means it having the two child node D and EF, and C as a parent means it having the F and G as the child. At the same time, the D as a we can consider as a parent means, so we are having the only one child node. At the same time, F we are having the parent node means, so we are having the two child. So now we can consider this is the level 0 and BC as the level 1, and then D, E, F, G as we can consider as a level 2. At the same time, we can consider for the H and then I, J as the level 3. Okay, so this is the explanation of the tree based structure. So now we can go with the step 1 process. So we can just move to the starting node. What is the starting node of the name? That is a node. Okay, so now we can just arrange with the queue and then visited node. Okay, what is the visited of the current node, and then making with the queue ordering with the help of the first come and then FIFO method, that is a first come first out method. Okay, so here what the thing is happening, first A we have visited, at the same time queue also we can make with the A. Okay, so this is one of the first starting level, and then the step 2. So what is the thing is happening here? So already we can make with the three connector thing. So first visit and then NQ and then DQ and then visited. So already we have visited, we can assign that the B and then A, and then now we can just what are all the Q steps in the ordering. So B and then C and then NQ is B and C. Okay, follow by the thing. So here what the thing? So A and then B and then C. Okay, the breadth first search it will be happening. So we can make with the this order A, B, C. Okay, so this is one of the level based thing. Now we can move with the step 3. Okay, so what the thing is happening here? So we have visited the previous node, that is a B, and then the making the order of the traversal A and then B, okay, and then the Q, what all the Q factor is available here. So C followed by the D and E, and the NQ position is D and E. Okay, so we can make with the structure and what all the nodes it has visited. Okay, everything we have note down in this order. Okay, so up to this E we have just noted the recording. And next one as the step 4. So now what the thing is happening here. So visited, what are all the visited node A, B, C. At the same time the visit position is current C, and the Q position is D, E, F, G. That is a breadth first. So that we can make with the order like that D, E, F, G, and NQ is the current position F and then G. Okay, so this is the thing happening for the level 2 base. Okay, so we can make with the structure in this order only: visit and then NQ and then Q and then visited node. And the next thing is what? So we can move with the H position. H, what is the level actually? This is for the level 3. Okay, so what the thing is happening? The current, the visit is Dth position. Okay, and then the next one as the NQ as the H position, and then Q position E, F, G, H. Okay, so here what all the thing is happening? A, B, C, D as the traversal tree. Okay, until now. So this is one of the H is happening for the third level. Okay, and next we can move into the visit E. Okay, so what the thing is happening? So visit E, the Q level is what all the Q level we are having? Just F, G, H. Okay, F, G, H as the F, G and then H as the Q level. Okay, and then the current position is I. Okay, so this is one of the happening for the step 6. And then the step 7 is what now? Visit of F. So what the thing is happening here? And then G and then H, and then make with the ordering for the G and H over here. Okay, and then step 8 here. So the visit of G is handling. Okay, the visit of G, it will be visited to the level is as the end of the level here. Okay, but the previous statement is what? H, I, J, and then NQ is what now? I, J. Okay, so this is one of the ordering state. And the step 9th position is what the thing is happening for the visit of H and then I comma J as a Q. That is all things are represented into the level 3. Okay, so now we can move with the step 10. Okay, what the thing is happening here? The visit and then Q. Okay, so we are having the two positions here. So visit of I and followed by the Q of J. Okay, so this is the current position. Finally we have just reach out the level 3. Okay, and after the J, so we don't have any kind of the values here. Okay, so that's why we can just make with the tree. So what are all the traversal order in this position? First A it should be connected to the B, and then B it should be connected to the C it should be connected to the D, and then D it should be connected to the E it should be connected to the F, and then F it should be connected to the G, and then G it should be connected to the H, and then H it should be connected to the I should be connected to the J. After that we don't have any kind of the names. Okay, so BFS visited the all nodes with the level by level based with the help of the Q method. Okay, so we can just record the all information as the current position and then before position, what are all the nodes it should be visited, everything we can just maintain with the in this order of the Q. Okay, so the next one now we are going to see with the time and then space complexity. Okay, so already we know what is meant by the time. So because in this search method we are just handling the 4 kind of the components as a very important components for comparing this. So the first one as the time complexity, and then second one as the space complexity, and then completeness, and then optimality. Okay, so the time complexity, always the BFS it will be just taking with the time based manner with the 2 kind of the parameters. Okay, so here we are having the maintaining for the B and then T. What is meant by the D first. This is one of the depth of shallowed, okay, shallowest method, depth of shallowest of the method. And B is what? So we are having the node of every state. We can just represent the state of the current position, okay, in the particular thing. So that's why we can make with that T of B equal to 1 B square T square up to the D in the big O of P of D. That is a B means what? The node of the every state, and then D means what? As the maximum depth of the shallowest. Depth means level based, okay, not in the bottom, okay, it should be the level based, that is a left to right position of the manner. And next one as the space complexity. So space complexity, it should be just talk about like the memory spaces only, and then memory size only. So it having like the frontier which O big O of B of D. So here the B means what? We are having the node of every state. At the same time, D means what? The depth of shallowest. So we have to maintain the these kind of the the space. We have to maintain the good numbering of size, memory size. That is the important thing for the space complexity. And then the next one is as a requirement, that is a parameter for the completeness. So completeness means what? So the BFS we have to, our target is we have to complete, and all the nodes it should be like visited. That is a primary condition over here, with the condition, with the technique for the Q method. That is one of the important thing. So it should be like a final the goal we have to reach out, okay. The every tree it will be starting, the starting position is it was started means we should just apply with the all technique. Okay, what is the technique in the it should be following for the BFS? Based upon the BFS we have to just roll out the each level, and then we will get the final goal, final solution. That is called as a completeness, okay. Not only the BFS, we can take with the DFS and then uniform cost method, and then what are the searching technique, not only the searching also, what is the technique we are having, okay. So we are having the problem, so we should just apply for the rules wise and then techniques wise, and then we will get the final goal, okay. So that is called as a completeness. The next one is as the optimality. So optimality means what? We can just find the path cost, but here we don't have any kind of the path cost. We should just maintaining the level based information only, okay. So that's why we can make with the non-decreasing the function of the depth of the node. So this is the expansion of the BFS. So BFS always we can just make with the tree or graph based structure, and these BFS it will be take over for the Q method. So in particularly the first come method, okay. So we can make arrange with the level based of the informations, and then we can roll out as the level based level, and then finally we will take the final outcome for the traversal tree ordering process, okay. So this is called as a BFS. The next we can move on to the DFS, okay. So already we have discussed the DFS. So in the this is one of the another problem over there, okay. So depth first search, this is the explore the one branch is very completely before the backtracking using the stack or recursion method, okay. It reaches the deepest node first before the exploring and remaining the branches. That is very important. And then DFS it start at the root node and continue until it is as the leaf node, until it will be just visit to the leaf node. And it can be used with the backtracks to visit the unvisited nodes also. And it should be just commonly used for the maze solving, and then topology sorting, and then cycle deduction and graph traversal problem also we can just take over the support for the DFS method, okay. So just look at the example here, okay. This is the general example as a process flow. So we are having the level based of data, 0 level, first level, 2 level, third level. So we can just move on to the depth first search like S to A and A to B and B to D. So here we are having the depth level, depth based level. So what is the starting of the node? Based upon the what is the ending node of the leaf node, we have to just move out to the depth level. And again we can just make with the backtracking of the nearest position, and then again it will be cached to the next level of the nearest position and nearest position of the next level. So based upon the thing we can make, and then we can travel with the next level of the process, okay. So this is called as a depth first search. So here the depth first search we can just applying for the recursive algorithm, like as the we can call it as a backtracking process, and we should just maintaining the stack method, okay. That is very important for the DFS. So this is the sample graph for the resolution. So first we can just take with the starting node of S. So once the S node is happening, the next node it will be visited to the A, and A followed by visited to the B, and B followed by visited to the D. So this is the last leaf node. Again it will be using the backtracking concept of recursive algorithm, and again back to move to the nearest position of E, and again it will be just backtracking process it will be applying, and then catch with the another nearby the node as the C, and then after that it will be just reach out the G. Okay, so G may be as the end of the portion, means we can wind up the process. Okay, so this is the traversal order of the depth first search. So S followed by the A, followed by the B, and then followed by the D, and then followed by the E, and then followed by the S, and then S it should be connected to the G as the final state of the process. Okay, this is one of the traversal order. So this is the thing, and next one as the another example for this is, so depth first search, it can be the explore the branches node. So in particularly we can start with the A node to the B node, and then the D it has as the children node, and using the backtracking process. So again the nearest position it will be visited to the B node, and then E node, and followed by the H, and then I node as in the followings, and it will be just considering the deepest node. That is very important, and we have using the backtracking process in the A, and then until the leaf node also. And here finally we can make with the final outcome is, this is the making with the traversal tree ordering function. Okay, so this is the thing we can make with the as the good level of the path level in the level based, and then we can just exploring the deeper nodes also. That is very important here. So now we can solve with the one example. So this is the tree. Okay, this is as the tree, and we are having the node of A as the parent node, we are having the B and then C as the child node, and whenever we can consider with the so B as the parent node means, so we are having D and E as the child node. At the same time, C as we can consider as a parent node means, we are having the child node of F and G, and followed by E as the parent node means, and H as the child node, and followed by H maybe we can consider as a parent node means, so we can just take with the I as the child node. So this is the tree order. This is the example of tree order. So now we can make with the level based, and A as the level 0, and we can fix with the 1 level 1 as the B and C, and we can fix with the like the 2 as the D, E, F, G, and follow by them the next level of the level 3 as we can fix with the H, and followed by the level 4, that is a 4 last level as we can fix with the I. So this is one of the level positioning order for which it could be just present in the tree. Okay, so first one is as the step one process. So first we can start with the current node is A node, 8th node. So now we can make with the recording information like the visited, at the same time stack. Okay, we can maintaining the stack method. Okay, so what is the first thing? A as the visited, and the current node is A, and the stack already stored in the visited node of A. Okay, so this is the step 1. The step 2 is what actually, so we are having the bth position. Okay, so now visited the node is A followed by the B, and here we have to just maintaining the record of A comma B. Okay, so this is one of the step 2 process. So now where we can present here, so we can present in the level 1. Okay, level 0 already we have visited, and then level 2 also we have visited here. Okay, now we can move into the step 3. So what are all the things it should be there? So now where we can present now, so we can present as a third level, that is a second level, okay, level 2 we can present. And now we are having the visit node is what? The current node is D, and what are all the visited node we are having? A followed by the B and followed by the D. Okay, and what are all the stack? It will be store the data like A comma B comma D. So we are having maintaining the stack in the A B D process. Okay, so now we have to just move to the backtrack to the B. Okay, because we don't have any nodes after the D. So that's why we have to just to do with the backtracking of the traversal method. Okay, so we can just maintaining the backtracking process to the B. Okay, so this is the order. So next we can go with the step 4. So what the thing is happening means, so now we can just visit the eth node, because with the help of the backtracking of D to B, and then we can just reach out to the E. Okay, so the visit node is what at present now eth node we can visit. Okay, in follow by that, so we are having the visited node is A followed by the B, and then B followed by the D, and then D followed by the, with the help of the backtracking process, and then we can reach out the eth position. Okay, eth position we can reach out. Now what is the level we are having at present? So we are having in the second level. Okay, so eth position we have reached out. Okay, so what are the stack values it should be recorded? So A comma B comma E. Okay, so 3 values it can be recorded, and then we have visited the, this is the traversal order. So now we can move into the next portion of step 5. So what the thing is happening here? Now the node is, we are going to visit H of node. Okay, because this is the end. After the E we are having the 2 nodes. Okay, H and then I. So we have to visit the leaf of the node of at present of eth level. Okay, so now after the eth level we have visited, we can just move to the H level. So visit is what? Visit not at present, so H. So H is the current position, and then what are all the nodes until now visited? So we are having the A, and then followed by the B visited, and then B to D, and then D to with the help of the backtracking position we can reach with the E, and then E to H. Okay, this is one of the traversal order, because E, after the E we are having the node, that's why we can just travel into the next position. Okay, H position. And what are all the names it should be recorded in the stack process? So we are having the A and then B, and followed by the E and H as the stack. It will be just maintaining the record of that level. Okay, so this is the tree structure. So now so for which level we are at present? So we are in the level of 3. Okay, third level we are present. Okay, so now we can move with the step 6. So step 6 we are having the tree structure for this, and now we can just move into the visit to the ith node. Okay, ith node, because after the H we are having the ith node of the thing. So that's why we can go with the visit of I. So here we are having the visited nodes of, what are all the node we have visited until now? So A followed by the B, and then B followed by the D, and then using the backtracking process we can move with the B, and then again go with the D, E, and then E followed by the H, and then H followed by the I. We have just visited for the traversal tree order. Okay, so now, so what are all the nodes of name it should be present in the stack, it should be recording in the stack means, so A followed by the B, and then B followed by the E, and then E followed by the H, and then H followed by the I. Okay, so the recorded the information of stack, so we are having the names for this. And now we can just check with the other node. So after the I we are having the node? No, we don't have any kind of the node after the ith level. So what the thing we are going to do? We should just apply for the recursive algorithm here. Okay, so backtracking process we should just apply over there. Then only we will get the next tree structure of the values. Okay, so now we can go with the step 7. So here at present level is what? Actually at present level is we are having the visit node of C. Okay, so C means what? That this position. Okay, because until after the visited of I, we can use the backtracking method. We can just travel into the Cth position. Okay, so Cth position as the current level, visit level. Okay, so now we want to make with the structure of traversal. So what are the order we have to follow? What are the nodes we have visited already? So we can make with the traversal tree structure. So first we can visit with the A, and then follow by the B, and then follow by the D, and then D, and then we can use with the recursive method again backtrack to the B, and follow by the E, and then E it should be just visited with the H, and then H it should be visited with the I, and then I, it should be visited with the help of the backtracking with recursive algorithm. We can just visit to the Cth position. Okay, so this is one of the until now of the current position of traversal tree. Okay, so next one we have to just maintain the stack record for A followed by the C. Okay, maintain the stack record. Okay, followed by the A followed by the C as the stack record. Now, for which level we are present now? So we are present in the level 1. Okay, level 1 we are present because the position is level 1 only. Am I correct? So this is the thing. So this is the process of the step 7. So after the C, so we can go with the Fth position. Okay, so what the thing is happening here? So here we are having the tree structure. Okay, we want to just move to the, after the C is visited to the Fth position. Okay, so here the visit of current node is Fth position, and we want to just make with the traversal tree order of visited record. The first one A followed by the B, and then B followed by the D, and then D followed by, with the help of the backtracking and then recursive method, we can go with the Eth position, and then E we have visited, and then E followed by the H already we have visited, and the H followed by the I we have visited, and then I we can just move to the move and then apply for the traversal algorithm. With the help of the backtracking process, we should just visit it into the, like what level, that is a Cth position level. Okay, C order, C name node we can visit it. Okay, once the C is completed, and then we can just come out to the Fth position of the order. Okay, so Fth we have to just reach out here. So this is one of the ordering of the traversal tree here. Okay, so now we want to just maintaining that recording information of stack. What are all the nodes we can just maintaining? A, and then A followed by the C, and then C followed by the E. We should FF, we should just recording the information of stack. So this is the position of explanation of the step 8. So now we are in the which level? Actually at present we are in the so Fth position. Fth position means we are just present in the level 2. Second position we are just present. Okay, so now we want to just move on to the next slide, that is a step 9th slide. Okay, where we can present now? So we can present in the Gth position. Okay, so Gth position as the we cannot conclude the final. So after the Gth position only we have to check is there any node it was present on. So now we can just move to the Gth position. How we can go with the Gth position? With the help of the backtracking method and then using the recursive algorithm, we can go with the F to the C, and then C it should be just visited to the Gth position. Okay, so what are all the traversal tree we are going to make? So first one A to B, and then B to D, and then using the traversal method we can just use with the Bth position, and then B it will be just go to the Eth position of the node, and once the Eth position we can visit, and then again we can come with the H position of the node we can visit, H to the ith position we can visit it, and after that we don't have any kind of the node, and then we just move into the Cth position with the help of the backtracking and then recursive algorithm, and then again we can just visit into the Fth method. Fth, after that, after the F we don't have any kind of the child node, so that's why we can move into the backtracking process, and then with the help of the recursive algorithm, and then algorithm to the Cth position. Again the Cth position we can just move into the next node of Gth position here. Okay, so this is the ordering over here. So here now we want to just make with the traversal tree order. Okay, so we want to make like the A to B, and then B to D, and then D to like what E with the help of the B, and then E to H, and then H to I, and followed by the backtracking level, and then backtracking with the help of the recursive algorithm level we should just connect into the C, and then C it will be connected to the F, and then F it will be just using the help of the backtracking level we should just visit it with the help of the recursive method to the C to G. Okay, so this is one of the traversal tree order. Okay, at present level. So now we are having which level of the thing now? G we are having in the at present level of level 2. We are in the level 2. Okay. So now we have to maintain the stack of information. Okay, at present level of A, C, G, at present level of the Gth level. So we can just make maintaining with the ACG of the level. Okay, so this is the thing. So now we want to move with the after the G. Okay, so after the G we are having any node is there? No, we don't have any kind of the node after G, because what now, this is the maximum level of the tree order. Okay, so at present we can start with the level 0. So level 0 as the 8th node, followed by the level 1, level 2, level 3, level 4, all nodes we have visited with the help of the DFS method. In the simultaneously we want to switch over to the other one position level to other position of level. Now we can apply with the backtracking method, and using the recursive algorithm we can just take with this help, we can move to the next level of the position. So in the final level it will be reach out as the second level, and the starting level is 0, and final we can just wind up the level is Gth position. So that's why we can mentioning like the level 2. Okay, so this is the ordering for making the step 9th process. Okay, so this is the final 3, because of what now, we don't have any kind of the nodes after that the G. That is the main thing. So now we can move with the next slide. So this is the ordering of the DFS ordering method. Okay, so A followed by the B, and then B followed by the D, and then D followed by the E followed by the H, and then H followed by the I followed by the C, and then C followed by the F followed by the G. Okay, so this is the DFS method of ordering. So this is the tree, as a basic tree. So based upon the base only we can just make with the DFS. This is the level based. This is the algorithm flow. So first what the thing we want to do, first start at the root node. Whenever we can fix with the start with the root node, and we can just go with the deepest method, because of this is the rule, DFS rule. We can just visit with the last level of the leaf node. Okay, again with the help of the recursive algorithm using the backtrack function, we can just switch over to the next level of the process. Okay, so this is the backtracking method, and next one, visit the remaining nodes. We can visit the all kind of the nodes that should be present in the tree function. Okay, so this is the called as a DFS method. Okay, this is the another example. And the next one we can just talk about like the time and the space, because this is the very important. Once we have solved the problem, okay, we should just discuss with the these 4 kind of the requirement over there. Okay, so the first one as the completeness. Yes, we have just completed. Yes, we have with the help of the DFS method. Okay, we should just apply the recursive algorithm with the help of the backtracking and using the stack process. Okay, each and every node we have visited successfully. Okay, with the help of the stack. Okay, we can help of the stack and follow by the recording the information of traversal tree. Okay, these 2 function we can just successfully we have visited the all nodes with in the particular rule. Okay, so that's why we have mentioned is that this is one of the complete within the finite state spaces, and we can apply for the all possible informations and then all possible rule in the state space method, and then we can just visit to the every node with the limited search tree. Okay, so this is called as a completeness. The next one as the time complexity. In the DFS of the time complexity, so we can make with the traversal node at the with the help of the algorithm, that is a recursive algorithm. So that's why we have to just maintaining time of n, and then followed by the 1 plus n square until the n of m. So finally we can make with the big O of n power of m. Okay, so here we can just make with the m means what, as the maximum depth of the any node, it should be present in the tree. Okay, and then already we know the d as the one of the shallowest path of the depth. Okay, so and then here we can just make with the n means as a node. Okay, n means as the node. So here we can just see with the depth of the process in the all time. The m means as the maximum of depth. So that's why we can just represent with the as a timing manner, because of we can just consider as the time of the maximum depth of level in the particular tree. That is very very important. Okay, so that is the thing. And this is the time complexity formula. Okay, the next one as the space complexity here. So here we are having the having the formula for big of b of m over here. Okay, so b means as a node of every visit, and then m as the maximum depth of the any node it could be present in the particular tree. So we want to just make with the size of the memory. Okay, so because we can use with the backtracking and everything, so that we can just maintaining the very very clear manner of the space complexity in the particular memory space. That is very very important, because of what now, every time we have to just move it until there is no in the leaf node, we have to move with the backtracking process. So that's why the space complexity is very very important of these process. Okay, space complexity process. Okay, so that's why we can just maintaining the big O of p of m. The next one, optimality or optimal. Okay, so that's why optimality means what, we don't have any kind of the cost value here. Okay, we can just make with the just reach out the like the technique of rules only, and then we need to just following the step by step process which should just reach out the final goal. Okay, so we don't have any kind of the just values over here. Okay, so that this is one of the complete finite state space search of the method. Okay, because what now, this is not as the one of the like no, not in the value based process. Okay, this is one of the non optimal value of process. Okay, we don't have any kind of the value, it will be just following the rules applying function, finally we will get we can just reach out the goal based. Okay, as a what is that, as a like the node based information, we don't have any values for representing and then concluding the process. Okay, we cannot able to decide as if with only the value. Okay, without the value only we have to move on to the DFS method with the help of the recursive algorithm with in the backtracking process. So that's why we can call it as a non-optimal process. But finally, we can just reach out the goal. That is very very important here. Okay, and next one is comparison of depth first search and then breadth first search. So now we can see with the advantages of the first and then follow by the disadvantages. So advantages of the first like the breadth first search, this is one of the guarantee to find the solution. Okay, at the same time this is simple to implement. So because the first statement is it will be just a guarantee for the finding the solution, and the same time the depth first search also it should be guarantee only. But here what now, it the level based level. Okay, that is a level now like left to right portion of the breadth based level, but this is called as a depth based, that is a deepest level. Okay, in the at last of the leaf node. So both thing was as the guarantee node only. Okay, guarantee answer only. The next one, breadth first search, this is one of the depending on the problem can be guaranteed to find the optimal solution. So it could be like a guarantee for the optimal solution. So because what now, we are having the limit of conditions. Okay, with using the queue method, and then like the queue in the first come first serve method, we can just make with the optimal solution in the particular rule. Whatever the rule we are having the breadth first level, we can just maintaining and then apply with the process over that. Okay, at the same time, so here we are having the depth first search, we are having the needs relatively small memory for the storing the state space. Okay, so here we are having the whatever the backtracking information is happening, what is the state space process is happening, because state space means all possible solution we need to find. Am I correct? So all possible way, everything we have to maintain into the each and every as the updation process. These updation process it will be maintained maintaining like the good spaces of the memory. Okay, every memory it should be just waiting for what all the updation is, it should be there in the tree based. Okay, so everything it will be observed and then it will be a recording. Okay, this is the main advantage for the depth first tree. Okay, because the breadth first, at the same time we are having the rule pattern, we can just trace out with the breadth level of left to right position. We know we don't we, it should be just maintaining the memory also, memory spaces also, but at the same time whenever we can compare with the breadth first to the depth first, we need to just storing the more data. Okay, more data, because why not? So we are having the at present, we can just move to the condition for what is the like the current position. We have to just travel to the next level of the process. Okay, so we want to check with the, is there any child process is there. Okay, so everything we have to the at the time we have to decide. Okay, so that's why it should be need for the more updation. Okay, updation on the memory side, that's why we can call it as a more advantage for the depth first search method. Okay, and the next one is disadvantages. So disadvantages, the first disadvantages of a breadth first search, this is one of the more complex to implement. This is one of the more complex to implement, because it could be just taking with the more and more complex. Now we cannot able to do, because it will be just very easiest concept, easiest way to solve. Okay, that is the one thing. And next one is can sometime fail into the fine solution. Whenever we can just reach out the like the level as the like the 8th level and then 10th level, means it will be just taking the more memory spaces in the updation. Okay, so because we are having the more and more leaf node, means okay, we should just maintaining the backtracking again backtracking, it will be going. Okay, so at the time maybe the space also memory space is very needed. Okay, at the time maybe it will be just cast into the fail statement. Okay, in particularly like what now in the spaces, memory spaces only. Okay, so we can increase the more and more child process, means the problem and process and solution definitely we will get it, but at the same time it will be taking the more and more memory spaces, because until the updation it will be coming for the whenever we can go with the child of next node. So that is the main drawback over that. And next one needs a lot of memory for the storing the state space if the search space has a high branches factor. Yeah, that is one of the main reason. So we are having the branch and then more and more branches, means so at the same time, so we are having the like the memory space is very lagging. Okay, so that is the main drawback for this breadth first search method. Okay, so same process, same problem only occur for the depth first search tree, but at the same time we need the waiting for the updation, that is very important. Okay, so here the disadvantage is like what, not guaranteed to find the optimal solution, not guaranteed to find an optimal solution, because of what, it don't have the any kind of the values. Okay, so because of that's why we cannot able to guarantee for the final solution. Okay, optimal solution, because not only the cost of the value, generally we can move with the next node level, means we cannot able to give the guarantee because of the depends to the leaf node only. Okay, that is the main problem. And next one as the can take a lot of longer to find the solutions. So here the lot of longer to find the solutions means what, the maybe we are having the more and more child, means it will be extend the limit. Okay, that is the main disadvantage for so we are having the like the depth first search at the same time as the breadth first search. Okay, the main the child node leaf node is as the main problem for taking the memory space and as well as the time constraint. Okay, so this is the thing for the difference. And now we have discussed the very basic and then another more complexity example for the another two examples also, and we have discussed the four constraints of the time complexity and then space complexity and then completeness and then optimality, and the four things are very important for the each search method. Okay, and then DFS as a very important thing, as a important node for take over the stack information, handling the information with the handling the stack of maintaining data only. So we can make with the, and then easy to find the solutions also. That is very important for the stack. Okay, at the same time, so we are having the just BFS method. We can just use with the queue method, that the queue we can just maintaining the data, and then in queue also we have to just maintaining data, and then finally each like a queue method and then stack also, it should be maintaining the both kind of the searching technique. And then whenever it will be just visited to the each node, that the node we can make with the pakka and then clear traversal tree over structure. Okay, that is very important. So we can just make with the clear structure of the tree, then only we can able to do the proper the tree of the traversal order. Okay, that is very important. Okay, so each node everything it will be recording the traversal order. Okay, that is the final outcome for the traversal method. And here these two things as the we are having the uninformed search method. Okay, and this are the uninformed search method as a useful for use this brute force method way. Okay, so brute force method way means we can just maintaining and analyzing the how to travel the traverse the tree, and then how what are the nodes it should be present, that also we need to focus. And brute force method, it will be just focusing on the identifying the leaf node. That is very important. Okay, that is very important for analyzing the leaf node. And then next one is as the final goal setter. So these also it will be just focusing as the uninformed search method. Okay, but sometimes so we can call it as the uninformed search as the blind search. Okay, already we know as the blind search. In the particular, why we can call like the blind search means, so we don't have any kind of the domain knowledge and then domain information. We don't have the more and more kind of the information also, and then rules also. Okay, that is the thing. And then we can apply for the brute force method way. We have to just do with the all kind of the process flow. Okay, that is very important. With the help of the find the traversal tree and find the identify and find the leaf node, and then finally we can just work with the goal node also. That is very important. So these two things it will be just as the types of the uninformed search method. So that is very important thing. At the same time, the BFS and then DFS, so we can just maintaining the these technique, two technique as a queue and then stack information. So at the same time, so we can just maintaining the time complexity level and then the optimal level, everything. Okay, but these two things we don't have the some particular certain value, so we can just apply with the rule of the breadth level and as well as the depth level. As a deeper level, we can just extracting our finding the proper solution in the optimal path. So we don't waiting for the any constraints of the value. Okay, so we can just maintaining and then finding the proper optimal solution with the help of the step flow functions. Whatever the step flow we need to follow for the breadth and follow by the depth, we can just generating our final outcome, not for the solution. That is very important. Okay, solution means what? As a value I am telling. Okay, value we cannot able to find. Okay, so this is not the path cost value, so we can just find the optimal solution value, because the path cost also we can just consider as a optimal solution now, because minimum or maximum. But these two search method we can find the optimal solution as they have given, or problem has given the final node, that is a goal node they have given. Based upon the node of the name we can reach out means, so we can consider as a path cost. Okay, so this is called as the optimal solution. We cannot consider the value for the both searching method, but we can consider the value for the uniform cost. Okay, so and then other searching problems for we can consider as a cost means as the value and the number. So that's why we can call it as a optimal cost of the solution or optimal solution writing. But here we can call it as a both way, as the optimal solution means whenever we are having the value we as the minimum cost means we can call it as a good optimal solution. At the same time, we don't have a value, but we can just find the proper solution Okay, so that's why we can call it as a non-optimal solution. That is the two difference. Okay, so that the thing we have to understand. Okay, so we can pass with the values means, and then we can find the shortest information means, okay, there is no issues, we are having the like the optimal solution, okay, or good optimal solution. At the same time, we don't have any kind of the value, but we can just work out the what are the rules it should be present in the particular problem, that based upon the particular problem we can work out, and then we can take with the final outcome, okay, without the numbers, okay, without the numbers. So that's why we can call it as a non-optimal solution over here. That the two things clearly understand. Okay, that is very very important, because we have to know like what is meant by the optimal solution and non-optimal solution, but both are as the optimal solution only, because what now, finally we have to just reach out the final goal. Okay, so we can just apply for the rules based, and then we will get the final outcome. Okay, so that's why we can call it as a optimal solution only, but we don't have a value means we can call it as a non-optimal solution, and at the same time we are having the value, so that's why we can call it as a optimal solution over there. Okay, so that is the main important thing. And here the both in for both the thing for as the searching method, we are having the leaf node in the next level means, the problem it will be just going into the like next level. Okay, so that's why, so we can just waste the memory. Okay, everything it will be lagging. So that is the drawback for the depth first and as well as the breadth first search method. Okay, until that it will be just okay for the all level. We can increase the level like ninth level or 10th level means, it will be going the next leaf node until untime. At the time it should be needed for the more and more memory. Okay, so that is the main drawback for the depth first search and then breadth first search. Okay, this is under the uninformed search method. We can call it the another name for the blind search method. Okay, so with the help of the brute force technique only, it will be happening for the all optimal solutions. So this is the another example, and then clearly we have explained the depth first search method and as well as the depth first search method. So thank you for watching.